Don't you just love math? I sure do. All right, let's talk about deductive reasoning. Deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. This is different from inductive reasoning, which uses specific examples and patterns to form a conjecture. Let's clarify a little. Inductive reasoning is when we took specific examples and patterns of specific things and we formed a general conjecture. So we tried to generalize and say, well, this is the rule for everything. Deductive reasoning, on the other hand, takes general things like facts, definitions, and accepted properties that are true in the general case, so true for all cases. And what we do is we try to come up with a specific conclusion regarding one certain case. Let's try to explore that and see what that really even means. Let's talk about what are the laws of logic. The first one we'll talk about is the law of detachment, which states if the hypothesis of a true conditional statement is true, then the conclusion is also true. Blah, 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 blah. Basically, what that means is if P implies Q is true, and P is true, then Q is true. So if you have a logical statement, and then you know that P is true, then you can conclude that Q is true. Por ejemplo, if Mr. McWhorter has $2 in his pocket, then he will buy a taco. So this is P implies Q. If P, then Q. And I will tell you right now that this is true. True. Oh, by the way, let it be known that Mr. McWhorter has $2 in his pocket. So that means that P is true. All right, so I have P implies Q, a true conditional statement, and then I come to find out, P is true. What can I conclude? Ding, ding, ding. I can conclude that Q is true. So my conclusion, good friends, by the law of detachment, is that Mr. McWhorter will buy a taco. Dun dun dun! The other law of logic that we're going to discuss is called the law of syllogism, which sounds like a silly name. Syllogism. Basically, if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. If these two are true, then if hypothesis P, then conclusion R is true. Blah, 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 blah. Try to simplify the little bit. If P implies Q and Q implies R, then Q is kind of like the bus station and P takes you all the way straight to R. I guess this is more like a layover in Vegas or Phoenix maybe. But basically, if P implies Q and Q implies R, then you can make the whole jump. Pew! P implies R. It's true. Example. If segment AB is congruent to segment CD, then the measure of AB is equal to the measure of CD. Or the length of segment AB is equal to the length of segment CD. That's true. By definition, in fact. Here's another one. If the length of AB is equal to the length of CD, then the length of AB plus the length of CD is equal to 2 times the length of AB. That is also true. By substitution, property of equality. Well, what should that mean? If this one implies this one, and this one implies this one, then this guy is really just a layover in London. So I can jump from the first one straight to the green one. So our conclusion by the law of syllogism: if segment AB is congruent to segment CD, then the sum of the lengths of segment AB and segment CD is equal to 2 times the length of segment AB. I hope the color coding helps a little bit there. Basically, it's just, you know, kind of put the things, it's like skipping stones. It's like step 1 takes you to step 2, and step 2 takes you to step 3. So that pretty much means anytime you start with step 1, you can get to step 3. Cool, huh? Example. If 2 segments have the same length, then they are congruent. You know that BC equals XY. So this means that segment BC has the same length as segment XY. So when there's no line on top, it means the length of the segment. So the length of BC is equal to the length of XY. So there's 2 segments with the same length. So here is my P implies Q. If P, then Q. If 2 segments have the same length, my Q looks like a G. Whoops. If 2 segments have the same length, then they are congruent. By the way, here's 2 segments that have the same length. What can I conclude? I can conclude then that they are congruent. So segment BC is congruent to segment XY. Ding! Using the law of syllogism. If possible, it's not always possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Alright, let's see what we got here. Let's call this one P implies Q. X squared greater than 25 is P. So this one's P. This one is not Q, so let's call it something else like R. So we have R implies P. So if we start up here, P implies Q is true, and R implies P. That doesn't seem like it's the same thing. But what we do have is, we have R implies P, and then P implies Q. So P is our bus stop slash layover slash stepping stone. So we can say we have R implies P and P implies Q. Hence, by the law of syllogism, R implies Q. So, if x is greater than 5, we may conclude that x squared is in fact greater than 20. By the law of syllogism. B. If a polygon is regular, then all angles in the interior of the polygon are congruent. So I'm going to call this P. If a polygon is regular, then all angles in the interior are congruent. I'll call that Q. So we've got P implies Q. And then down here, if a polygon is regular, well, there's P again, then all its sides are congruent. So I'll call that R. So down here we've got P implies R. P implies Q and P implies R. That doesn't give us P implies R. We don't have a layover right here. This isn't the same place. We have P giving us 2 different conclusions, but we don't have a bus stop layover type of a thing like we did here. R takes you to P, and then P takes you to Q. We have P takes you to Q, and then P takes you to somewhere else. Well, too bad, because I'm not at P anymore. I'm at Q now. That's great that P can take me to Q and R, but once P took me to Q, I'm at Q. I need Q to take me somewhere if I'm using the law of syllogism. And so no conclusion can be made using the law of syllogism. And that, my friends, is the end of the lesson.